Okay, so today we're going to be finishing up Unit 9, Lesson 1. We did writing equations of parallel lines yesterday, so today we're going to be writing equations of perpendicular lines. So we already did that whole first page of notes, and we're moving on to the second page now, where we can see perpendicular lines at the top. Okay, so in the past we've learned that perpendicular lines are lines that intersect at 90-degree angles. So perpendicular lines are just two lines that intersect, and where they meet at a 90-degree or right angle. Actually, all four of those angles in there right where they meet are 90-degree angles. All right, so their slopes are going to be negative reciprocals of each other. So unlike parallel lines, which have the same slopes, perpendicular lines have slopes that are negative reciprocals of each other. If you recall back to yesterday's do now, remember when we graphed those perpendicular line segments, the ones that we created by doing a 90-degree counterclockwise rotation, we found that when we found the slope of each of those line segments, they were negative reciprocals of each other. One was positive, one was negative, and the fractions were flipped, which is what reciprocal means. All right, so today we're going to be looking at that. Whenever you have negative reciprocals, if you multiply those together, you're going to get -1. All right, so for the first example here, it says find the slope of segment AB with endpoints of 2, 2 for A and for B 10, 16. All right, so for the first question, the only thing they want us to do is find the slope. All right, so we need to use our slope formula. So that's going to be M equals y2 minus y1 over x2 minus x1. All right, and then we're just going to plug in. So I'm going to have A be my x1, y1, and B is going to be x2, y2. And we're going to substitute right into our slope formula. So for y2 minus y1, we're going to get 16 minus 2. And then on the bottom, x2 minus x1 is 10 minus 2. Now remember, don't type the whole thing in the calculator at once. If you do that, you're going to get the wrong number because the bottom won't have been grouped. So we just want to do the top on its own. 16 minus 2 is 4. And then the bottom on its own, 10 minus 2 is 8. And then if possible, we'll also reduce. So always check to see if these can be reduced. And this one, 14 and 8 are both divisible by 2. So we get 7 over 4 for the slope of the line segment AB. So the next part of that question says, what would the slope of a segment that's perpendicular to AB be? So our key word here is perpendicular. And if we look back up at the top, we know that perpendicular lines have negative reciprocal slopes. So if the slope of AB is 7/4, the slope of a segment perpendicular to AB, so our perpendicular slope or perpendicular M or slope, we would take our fraction, flip it upside down because that's what reciprocal means from negative reciprocals. And the negative just means we're going to change the sign. So our negative reciprocal slope, we change the sign to a negative, and we flip the fraction and we get -4/7. So our perpendicular slope is just going to be -4 over 7. Okay, and to check the answer, if you wanted to check the answer, we would just prove that when we multiply those together, we get -1. So we can always check by taking the original slope and multiplying it by the new slope, which is -4/7, the one after we did the perpendicular, the negative reciprocal. And if we multiply this together, you can always check in the calculator or multiply across the top and across the bottom, but we do get -1. So we just found those negative reciprocal slopes of perpendicular lines. All right, so now let's try our next example. So the second example says the lines whose equations are 2x plus 3y equals 4 and y equals mx plus b will be perpendicular when m is equal to what? All right, so we have to figure out what this m is, and if we look back at our equation, m is right here. So we're trying to find the slope of this second line. All right, and we know that the lines are perpendicular because I can see that my key word right here is perpendicular. So whenever we see perpendicular for our key word, we want to start thinking negative reciprocal slopes. Okay, so we're going to try to find a negative reciprocal slope to the slope of the original line. All right, so if we look at the original line is 2x right here plus 3y equals 4. Now, if I could find the slope of this line, all I need to do is take the negative reciprocal of it to get the m that I need in the other line. But in order to find the slope in this line, we have to solve for y. We have to get this in y equals mx plus b form. We can't find the slope unless the line is solved for y, the equation. So we're going to start by moving the x's to the other side. So 2x minus 2x cancels out. That equals 0. We're going to bring the 3y right down. And then remember, when we're solving for y with lines, we always bring the x's down first and then the constant down second. So I'm going to bring that negative 2x down first and the positive 4 down second. And then let's undo that multiplication by using division. Now here, negative 2 divided by 3, we get a decimal, so make sure you bring that back to fraction form. We end up with negative 2/3 x, and then same thing here, 4/3. We would get a decimal, so we want to bring that back to a fraction, and we end up with 4/3. So this is the equation of the original line. That's this one right here. Okay, so if we look at the slope of the original line, it's negative 2/3. So if we wanted a parallel line, the slopes of the parallel line would also be negative 2/3. But this time it's switching things around. We want the perpendicular line this time. So remember, perpendicular lines, if we look back up at the top, have slopes that are negative reciprocals. So if the slope of this line is negative 2/3, we'd have to find the negative reciprocal of negative 2/3. So our perpendicular, remember that upside down t just as a shortcut for saying perpendicular. Our perpendicular slope, we'd have to change the sign. That's when it means the negative part of negative reciprocal. So if it's already negative, we're going to change it to a positive so we don't have to write a sign at all. And then reciprocal just means flip the fraction. So our perpendicular line slope is going to be 3/2. So again, negative just means change the sign, and reciprocal means flip the fraction. Okay, so we found our answer. It is going to be choice 3. Okay, so let's try another example. All right, so our next example says, what is an equation of the line that passes through the point 2, 4 and is perpendicular to the line whose equation is 3y equals 6x plus 3? So this goes back to writing equations of lines. We have our point, so that's going to be our x and y values. And then we need to get the slope of the original line and then use a slope that's perpendicular to that line. So remember, perpendicular lines have negative reciprocal, I think I just spelled that wrong, slopes. So the first thing we need to do is get the slope of the original line. Before we can even start writing our equation or solving for b, we need the slope of this original line. So I'm just going to rewrite it and solve for y. So I'm going to divide each side by 3. And we get y equals 2x plus 1 when we divide everything out. So the slope of the original line is 2. So remember when we did parallel lines, we used that same slope because parallel lines have the same slopes. But this time we have a perpendicular line. And we know perpendicular lines have negative reciprocal slopes. So I'm not going to use 2. I'm going to take the negative reciprocal of that. Now, if this is not a fraction, we can turn it into a fraction by putting that 2/1 so we have something to flip over. So I have a positive 2 or a positive 2/1 for my original slope. So negative means we change the sign to negative and we flip the fraction. So that's going to be negative 1/2. So this is the slope I'm going to use for the rest of the problem. So right now I can cross everything out that doesn't have a slope of negative 1/2. So I'm going to cross 3 and 4 off because they have a slope of 2. I'm going to leave 1 and 2 since they both have a slope of negative 1/2. We just have to find the y-intercept now. All right, so we're going to go back to writing equations, which is where we plug a y, an m, and an x into y equals mx plus b, so that we're only left with b as our variable so we can solve for it. So remember, the x and the y, just like we did yesterday, come from our point. X is 2, y is 4. So I'm going to write 4 equals. Now remember, there's 2 different slopes. We have to choose the perpendicular one because we're trying to write a perpendicular line to the original. So we want to use the new slope, that perpendicular slope, for our m. And then our x is 2, and we'll bring down that b. All right, we're going to multiply right here. We get 4 equals negative 1 plus b. And then we can add that 1 to each side, giving us 5 equals b. So now we have everything we need to write our equation. Again, we're not using that original slope. We're using the perpendicular slope because we want a perpendicular line. So when we write our equation, it's going to be y equals -1/2. Bring down your x, and then the b value is going to be a +5. So this would be our final equation, y equals -1/2 x plus 5. So that's going to be choice 1. Okay, and then we have our last example here. All right, so in the diagram, triangle ABC has vertices of A25, B57, and C41. What is the slope of the altitude drawn from A to BC? So the first thing I want to do is look at that word altitude. Altitude is just another word for height. And remember, height is always perpendicular. That's our key word for today, to the base. So our height is going to be drawn from A to BC. So A is going to be perpendicular to BC. You can kind of sketch it, and it might not be perfect, but you're going to draw a line segment that's perpendicular to BC. So in order to find the slope of this altitude, so our goal is to find the slope of this orange line segment I just drew in, we first have to find the slope of the segment that it's perpendicular to. So we know B is 5,7 and we know C is 4,1. They also gave us A, but we really don't need that at all for this one, because once I find the slope of this segment using these 2 points, I can then just do negative reciprocal, because an altitude is perpendicular to the base, and we know perpendicular lines have negative reciprocal slopes. So whatever this slope is, I'm going to take the negative reciprocal of it to get this slope. All right, so we're just going to use our slope formula in this one. So we're doing the slope of BC. So we're using m equals y2 minus y1 over x2 minus x1. Again, A has nothing to do with this problem, so I don't even need it. You can cross it out if you want. And then B, I'm going to name x1, y1, and C, we're going to name x2, y2. So when we substitute in for the slope of BC, y2 minus y1 is going to give us 1 minus 7. x2 minus x1 is going to give us 4 minus 5. And we end up with -6 over -1, which simplifies to 6. So that's our original slope. But remember, we want the slope of the altitude, which is perpendicular to that line segment that has a slope of 6. So now our altitude, all we need to do to find the slope of the altitude is take the negative reciprocal of 6. Now, if you want something to flip, you can always put the 6 over a 1. So remember, negative reciprocal means change the sign of the slope. So I'm going to change it to a negative from a positive. And then reciprocal means flip the fraction. So my new slope of my altitude is going to be -1/6 for our final answer. Okay, and that's it. All right, so for homework tonight, I'm just going to have you guys finish up the homework page. So that would be questions 2, 5, 6, and 7. And that's it for today.